So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing the revision theme of the AQA GCSE Maths 2022 Foundation Paper 2, which is a calculator paper with a focus on the geometry and measure section. Now there will be a copy of the questions that I go through in this video for you to download and have an attempt at before or during watching this video for it to make sense. So before we get started going through some example questions, let's just have a look at the advanced notice of what topics are going to appear on the geometry and measure section for the foundation paper 2. So looking at the shapes, we're looking at drawing shapes. So this is going to basically include being able to draw common polygons, so hexagons, octagons, nonagons, etc. Remembering the properties of diagonals, constructing the shapes, in other words, drawing them accurately, recognizing shapes and also their names and their general properties. So in terms of parallel lines, perpendicular lines, etc., equal lines that have equal length, etc. Now, when it comes to quadrilaterals, again, there are several types of quadrilateral you need to be able to know. So just to name a few, you've got square, rectangle, rhombus, parallelogram, trapezium, and it's important that you do know the differences between each of those quadrilaterals, and also if you're given a description of one, to be able to identify which quadrilateral it's going to be. In terms of parallelogram, that might be linked with quadrilateral in itself. So again, learn the properties of a parallelogram, know how to draw it accurately using a compass and protractor, and also the formulas to work out the area and perimeter. Parts of a circle, well, that's going to be quite self-explanatory. You need to learn all the parts of a circle, so be able to identify a sector, a chord, a tangent, a major arc, minor arc, major sector, etc. And then you've obviously got the typical ones of a radius, diameter, and circumference. Then moving on to Pythagoras, again remembering the formula, remembering how to label the triangle. You want to work with reverse questions, so when you're trying to find one on the smaller side, so don't think always you're finding out the longer side. Practice working with decimals, remembering to square root your final answer. Also work with worded problems and two-step questions as well, where you need to use Pythagoras twice. I won't say you need to go into 3D Pythagoras on the foundation paper, but questions where you need to find the side of another triangle which are not kind of explicitly given, to find out what it is you're actually trying to find. And also remember, try and learn some Pythagoras triples, at least understand what they are. Now, Pythagoras triple is where all the sides of the right angle triangle are all whole numbers. With time problems, again, I would say it could easily come up with converting time units, so seconds into hours or seconds into minutes and days, etc., and also working with timetables as well, and that could either be bus timetables, holiday timetables, flight timetables, etc. Then with compound shapes, again looking at area and volume, so you want to work out the area and perimeter of common polygons and flat shapes in terms of triangles, trapeziums, rectangles, parallelograms, and learn all those formulas, kites, etc. And also included in that is surface area, because the fact that it's mentioned under volume basically means also it includes volume. So know how to work out the volume of a prism, work out surface area of prisms, and learn all the formulas and of the basic polygons. So before we get started on these questions, just a little reminder that you can access these questions by clicking on the link in the description below and either have an attempt at those questions before watching this video or while we go through the answers. So looking at question 1, it says that a quadrilateral PQRS has PQ, which is 5 centimeters, QR, which is perpendicular to PQ, QR, which is 7 centimeters, and the angle QPS is 135 degrees, and P to S is 8.5 centimeters. On the grid, draw the quadrilateral PQRS. PQ has been drawn for you. So what we need to do is we need to use these properties and these facts to then draw this quadrilateral. Now, one thing you might want to do is do a little sketch, but again, sometimes it may be unnecessary. So this is PQ, not drawn very correctly. Then R is going to be perpendicular, so it's going to be over there. And then S is going to be somewhere over here, where the measurements are this length here is 5 centimeters, this is 7 centimeters, this is 8.5 centimeters, and this angle here is 135 degrees. So that is exactly what we need to draw. Now on the computer it's going to be very difficult for me to do that, so let me just give you an idea of what it should look like. So if we assume that each of these squares is 1 centimeters in terms of length, then doing this relatively correctly, this line here needs to be 7 centimeters. And again, you want to try and be as accurate as possible. So let me just label this up. So this line here is 7 centimeters. Now for the next one, what we need to then do is use our protractor and measure 135 degrees. Now that is going to be basically going through those diagonals. So let me just try and do that accurately. Now what you would do is you'd put your center of your protractor at point P, and then using either the outside numbers or inside numbers, you want to draw an obtuse angle of 135 degrees. So if I just label this, what I've done is that this angle here needs to be 135 degrees. Now the only thing left for me to then do is to measure 8.5 centimeters. So with my compass, and I'm just doing a little sketch of what that should look like. So here is the rough sketch of the pencil, and here is the pin. So this length here needs to be 8.5 centimeters. And then what we then need to do is put the pin on P and then swing an arc so that we get 8.5 centimeters. So if I imagine that 8.5 centimeters, so let's just go for 3, 6, it's going to be somewhere around here, let's say. So if I just draw an arc, but this length here needs to be 8.5 centimeters, and then the only thing left for me to do is then mark a little dot at where the line of PS of this purple line meets the arc, and then just draw a straight line from that intersection point to this point here, making our quadrilateral. So it should look something like this. Now obviously my position of S might be completely different to yours, and this is R, but it should look something that looks like that. And again, under any circumstance, do not rub out your construction lines basically. So make sure you keep your compass marks, make sure you keep your lengths, and like I said, with it being worth 4 marks, you're looking at getting P in the correct place, R in the correct place, and have an attempt at working out what S is. So moving on to question 2, again looking at another construction question. So here it says, using a ruler and protractor, draw this triangle accurately. So what we need to do here is first of all get our protractor. So we'll just do a little sketch of what the protractor looks like. And then what you then want to do is measure an angle of 40 degrees. Let's just mark it as there. And then with a ruler, what you then want to do is from point A is draw a straight line from that marking of 40 degrees, like so. And you should end up with something that looks like this. Let me just change that color so it's a bit more obvious what I've done. So this angle here needs to be 40 degrees. Then what I then need to do is now get my protractor on point B. And again, what I then need to do is measure 55 degrees. So again, whatever your protractor is saying, put a marker where 55 is. So let me say it's going to be around about here. And then what I then want to do is draw a straight line through that point from P. And what you should find is that those two lines then meet. Like so. Now again, mine's not drawn accurately at all, but hopefully yours will, and hopefully you understand the steps that get you to draw that triangle accurately. So moving on to question 3, it says tick all statements that are true for any rhombus. Now again, a rhombus, and it's always worth with these types of questions, is to try and draw an accurate drawing of that. Now with a rhombus, all the sides are the same length. So the diagonals are the lines of symmetry, and these are the diagonals, so that is true. The diagonals bisect each other, that is true. The diagonals are perpendicular, that is true. And the diagonals are equal lengths, that's false. So the top 3 boxes need to be ticked. Question 4, it says on a circle, which of these is always longer than the diameter? And the correct answer you should have is going to be the circumference. Then with question 5, it says on a circle, which of these is not a straight line? And the one that's not a straight line is the circumference. For question 6, it says circle. Oh, don't know what's happened there. So let's get that question back up. For question 6, it says circle the word that describes the straight line PQ, and that is a chord. Then question 7, on the circle, which of these is the longest? And it's going to be the circumference. Now, just a word of warning that the answer for any question that relates to parts of a circle is not always circumference. So question 8 says that O is the center of the circle, and it says circle the word that to complete each sentence. So the line OA is a radius. The line MN is a chord, and the line ST is a tangent. Then moving on to question 9, it says draw the following on the circle below. So we want to draw the radius. So again, what you then want to do is with your ruler, is draw a line from the center to the circumference. And it can be absolutely anywhere, but as long as it goes from the center of the circle to the circumference, then that's absolutely fine. To then draw a chord, again, all we need to do is just basically draw a line from one end of the circumference to another, but make sure that it doesn't go through the center point, like so. And then the tangent is basically a straight line that touches the circumference at one point only. And again, these could be drawn absolutely anywhere. It doesn't need to be exactly to what I've done on the screen. Question 10 looks at Pythagoras. So it says calculate the length of x. So the first thing I want to do is label the sides. So again, this is going to be A, this is going to be B, and this is going to be C. So I've got 25 squared plus 43 squared equals x squared. And then working this out. Now again, try not to be too lazy in your working out. Obviously it's worth 3 marks. So make sure we're writing this down. So 2474 equals x squared. So x equals the square root of 2474. Now the question does not insist on any form of rounding, so you can either leave your answer as 2474 or you can write it as a decimal, but just if you are rounding it, make sure you state what you round it to. So I'm going to round this to 1 decimal place. But again, if you're not sure about your rounding and there's no specification in the question, then simply all you could do is just copy what's on your calculator, and that will give you full marks. Moving on to question 11. Again, it says work out the length of AC, so I'm just going to label this as X. So then labeling the triangle, I've got C, A, and B. So here, what I've then got is, well, actually, let me change B and A around. So always trying to make your life a little bit easier. Whichever the smaller side you're trying to find, label that as A, and the given side of which you've got a number for, label that B. So then from this, what we've got is we've got x squared plus 9 squared equals 20 squared. So x squared equals 20 squared minus 9 squared. And again, typing that into my calculator, I get an answer of 319. So x squared equals 319. So x equals the square root of 319. Now this question does say for you to round your answer to 1 decimal place, and that then becomes 17.9, and that's to 1 decimal place. Moving on to question 12, again we've got another Pythagoras question. So it says calculate the length of x. So again, if I label this as C, I'll label x as A and B as 48. So then simplifying this, what we get is x squared plus 48 squared equals 73 squared. And then we get x squared equals 73 squared minus 48 squared. Now, sometimes people would start off by writing this line here, which is absolutely fine. You're not going to lose any marks for that. So then typing the rest in the calculator, 73 squared, take away 48 squared. We get an answer of 3020, 3025 rather. So x equals the square root of 3025. Now I could leave my answer as this, or I could write it as a decimal, in which if I just type that in, I get an answer of 55. Moving on to question 23, it says here is a right angle triangle. Show that x equals 12. So for this, I'm just going to ignore this, but my answer should be 12. So from this, if I label the triangle A, B, and C, then I get 9.6 squared plus 7.2 squared equals x squared. Then 9.6 squared plus 7.2 squared equals 144. So x equals the square root of 144. So x equals 12, which is what they wanted me to show. Moving on to question 14, it says in the diagram, the area of the triangle is 56 centimeters squared. Work out the length of CD. Now, obviously, we've got two right angle triangles, so you're automatically thinking Pythagoras. But the problem about working CD is I need to know what this length here is. Now, the side that I'm actually wanting to find is CD, which is this. I'm just going to call that X. So this I'm going to call H because it's the height of the triangle. Now, using this bit of information, I know that the area equals base times height divided by 2. So then substituting the numbers in, I know that the base of the triangle is going to be 14 plus 6, which is 20. So 20 times h divided by 2 equals 56. So then 20h equals 2 times 56, which is going to be 112. And then h equals 112 divided by 20, which if I work out on the calculator gives me an answer of 5.6. So this length here is 5.6. So now I can use Pythagoras. So here I've got 5.6 squared plus 6 squared equals x squared. Then 5.6 squared plus 6 squared equals 67. So x squared equals 67.36. So x equals the square root of that. And if I again type that into my calculator, I get an answer of 8.2. And that's to 1 decimal place. Moving on to question 15, it says E is the center of the rectangle of ABCD. And the question is asking me to work out the length of DE. So it's asking me to work out what this length here is. Now, from this, well, I can know that E is at the center of the rectangle. So if it's at the center, it's going to be half of AD, which is 6, and it's going to be half of 20, which is 10. So then from this, if I just label DE as x, I've got 6 squared plus 10 squared equals x squared. So then I've got 136 equals x squared. So x equals the square root of 136. And again, if I type that into my calculator, I get an answer of 11.7. And again, that's to 1 decimal place. Again, there's no specification of what they want around it. So if I wanted to, I could copy what's on the calculator. So I could write the answer as 11.66190.379. And again, just in case I'm feeling a bit anxious about my rounding skills. Then moving on to question 16, it says Samir and Dan run a race. Samir finishes in 2.5 minutes and Dan finishes in 130 seconds. Complete the following sentence. So we need to know who won and by how many seconds. So let's first of all convert Samir's time into seconds. So 2 minutes equals 120 seconds and half a minute equals 30 seconds. Then the total for Samir is going to be 150 seconds. So what I need to do is compare 150 to 130. So here the answer is going to be Dan wins by, and it's going to be 20 seconds. Moving on to question 17, it says Alice does a sponsored walk. She starts from Monday on at 8 a.m. She arrives back home 55 hours later. Work out when she arrives back home. So 55 hours, what we want to do is work out how many 24 hours and how much is left. If I do 55 divided by 24, so 55 divided by 24, and that gives me an answer of 2. So it's going to be 2 days. And then how many are left? Well, 2 times 24 is 48. 55 minus 48 is going to give me 7 hours. So here it's going to take 2 days and then 7 hours from 8 a.m. Well, that's going to be 9, 10, 11, 12, and then 1, 2, 3. So it's going to be 2 days later and I've forgotten the time already, 9, 10, 11, 12, 13, 14, 15 at 3 p.m. and the day that she's going to be deriving is going to be Wednesday. So actually, let me get rid of this, and it's going to be Wednesday. Now, if you wanted to write it as a 24-hour clock, then that's absolutely fine as well. Question 18 then says that which is longer, 3/4 of a day or 100 minutes? So what we want to do is convert both into hours. So 3/4 of 24 hours is going to be 18 hours. And then 1,000 minutes divided by 60, see how many hours there are, is going to be 16 hours. And then to work out how many minutes are left, if I just do 16 times 60, which is 960. So it's 9 hours and 40 minutes. So which one is longer? It's going to be 3/4 of a day. Then for question 19, it says circle the length of time between 1:50 and 3:35, and the correct answer we should have is 1 hour and 45 minutes. Then for question 20, it says the time in Rio is 3 hours behind London. The time in New York is 5 hours behind London. What is the time in New York when it's 1 a.m. in Rio? So here what we've got is we've got London, we've got New York, and we've got Rio. So let's have a look. So Rio is 3 hours behind London. So let's put Rio here. So London to Rio. Actually, I've got those the wrong way around. So let me just write that there. Rio and New York. So this time difference is -3. And this time difference here is -5. So here the difference between these two times here then is -2. So if the time is 1 a.m. in Rio, then it's going to be 1 a.m. take away 2 hours, so -2 hours, and that's going to be 11 p.m. Or if you want to write it as a 24-hour clock, 2300. Question 21 says how many minutes are there in 5.5 hours? Well, it's going to be 5 times 60 plus, and then 1/4 of an hour is 15 minutes. So it's going to be 315 minutes, which is our first answer. And question 22 says how many minutes are there in 225 seconds? So again, we're just going to do 225 divided by 60, and then it's just a case of simplifying that. But again, as it's on the calculator paper, if I just work that out, it's 15/4, and which gives me 3 3/4, which is our last option. Question 23 then says how many minutes are there in 2.25 hours? So 2 hours equals 120 minutes, and then 1/4 of an hour is 15 minutes, so it's going to be 135, which I think is a repeat of the previous question. Moving on to question 24, it says that the first part of a show starts at 7:45 p.m. It lasts 35 minutes. What time does the first part end? And the answer we should have here is 8:20 p.m. Again, if you want to go rogue and write it as a 24-hour clock, then it'll be 2020. And for B, it says after the first part there is a 20-minute break. The second part lasts for 45 minutes. What time does the second part end? So after the first part there is a 20-minute break. So from 8:20 p.m. it then goes to 8:40 p.m. and then we then want to add 45 minutes. So then what time does that then become? Well, it's going to be 9:25 p.m. or 21:25. Then moving on to compound area or perimeter question, it says the diagram shows Adam's garden. It is the shape of 2 rectangles joined together, and the question is asking us to work out the area of the garden. So what you want to do here is be able to split the shape up into those 2 rectangles. So if I just call this area A and this area B, so then what we've then got is area A, which is going to be 2.3 times 4, and 2.3 times 4 is 9.2. And then for area B, That's going to be 4.5 times 6.4. And again, making sure that you are showing your working out, which gives me an answer of 28.8. And then all I then want to do is add those two numbers up, which gives me an answer of 38 meters squared. It then says that Adam makes a flower bed. It is a circle with a radius of 1.7 meters. Work out the area of the flower bed. So for this, all I need to do is work out the area of the circle. So it's going to be pi r squared. So it's pi times 1.7 squared, and 1.7 squared times pi is going to give me an answer of, and as a decimal, it's around about 9.1, and that's to 1 decimal place. Then moving on to question 26, it says that a shape is made using 15 identical rectangles. Work out the area of the shape. So for this, what we want to try and do is, if I call the length of the rectangle y, x, and the height of it being y, then from this we know that 3x equals 16.2. So x equals 16.2 divided by 3, which gives me an answer of 5.4. Then working this out then, so what I've then got is working with this length here, I've got y, and then I've got x, I've got y, x, and y. So from this, I've got 2x plus 3y also equals 16.2, but I know what x equals. So I've got 10.8 plus 3y equals 16.2. So then 3y equals 16.2, take away 10.8, which gives me 5.4. So then y equals 5.4 divided by 3, which is 1.8. So then to work out the area, well, the height of this rectangle is going to be 1.8 plus 1.8 plus 5.4. And 1.8 plus 1.8 plus 5.4 is 9. So then the area is going to be 9 times 16.2, which gives me an answer of 145.8. Then moving on to question 27, it says the perimeter of this L shape is 56 centimeters, and it says set up and solve an equation to work out the value of x. So what we first need to do is we need to work out what this length here is. Now, if all of this is 4x and this little bit is x, then that means that this length here is going to be 3x. And similarly for this length here, if all of that length is 4x, this length here is 2x, this must be the difference, so that there must be 2x. So then forming the equations, picking a point and then just going all the way around, I've got 2x plus 3x plus 2x plus x plus 4x plus 4x. And again, that all equals 56. So then neatening up the left hand side, I've got 2 plus 3, which is 5, 7, 8, and then 16x equals 56. So then 56 divided by 16 gives me 3.5. So x equals 3.5, and it's going to be in centimeters. Now again, with this, you can see that there's no centimeters on there, so make sure you are writing it, because potentially one of those 4 marks is going to be for the units. So let me just write down, don't forget the units. Now it's always going to be one question where the units are not given to you. Typically they are, but if it's not, you'll get a mark just fine. So even if I wrote 35 million centimeters, then at least I might get 1 mark for just writing 30 centimeters. Moving on to question 28, says the perimeter of the square is 48. Semicircles are joined to the 2 sides of the square. Work out the perimeter of the shape. So first of all, let's work out what each of the sides are going to be. So if the perimeter is 48, then the side of the rectangle is going to be 48 divided by 4, which is 12. So this length here is going to be 12. So from this, what I can then do is work out the perimeter of this. So if I know that this length here is 12, So P equals 12 plus 12. So the next thing I've then got to do is work out what this length here is. Now that is a semicircle and circumference, half the circumference. So it's going to be pi times d divided by 2. Now the diameter of that circle is 12. So it's going to be pi times 12 divided by 2, which leaves me with 6 pi. So that length there is going to be 6 pi. This length here is the same as the other side. So if that's 6 pi, this is going to be 6 pi. So adding all of it up, I get the perimeters being 24 plus 12 pi. And then if I just type that all into my calculator, so 24 plus 12 pi, I get a decimal answer of 60. Oh, don't know what's happened there. I get an answer of 61.7, and that's been rounded to 1 decimal place. I don't need to write the units because the units are given to me. Then for question 29, it says the diagram shows, and oh, we've got a repeat of a question. So this question is exactly the same as, I'm trying to remember which question it was, as question 25. So I won't bother answering that one. Apologies for the repeat of question. Oh, we've actually got a bonus question here. So it says that Adam says that the area of the flower bed is less than 25% of the area of the garden. Is he correct? So if I just go back and write down those answers. So the area of the garden was, let me just go back to those possible two answers. So 38 and 9.1. So 38 and 9.1. So the question then says that the area of the flower bed is less than 25% of the garden. So if the flower bed was 9.1, the total garden was 3.8. What I want to do and multiply that by 100, I can then work out what the percentage is going to be. So 9.1 divided by 38, and now I've put 3.8, so let me just get rid of that. Multiply that by 100, and I get a percentage of 23.947%. And so Adam is saying it's less than 25%, so yes, he is correct. Then moving on to our last question, it says that a hexagon is made from a rectangle and two congruent triangles. So congruent triangles basically means that the two triangles are the same. And the question is asking us to work out the area of the hexagon. So again, if I call this area A, and because these triangles are the same, I'm just going to call it B. Now, to work out the area of a triangle, I need to know what the height is. So if the middle height is 13 and all of it is 21, so if I do 21 take away 13 divided by 2, so 21 take away 13 divided by 2 gives me 4. So this length is going to be 4, and this length here is going to be 4. So the area of A is 13 times 18, which is 234. And area of B is going to be 4 times 18 divided by 2. So 4 times 18 divided by 2 gives me 36. So then the total area is going to be 234 plus 2 lots of B. So it's 234 plus 36, which gives me a final answer of 306. And that is it.